many people, a trip to the moon sounds like an exciting adventure. However, astronomers warn us that the moon is a very uninviting place. They tell us it has no atmosphere or water, and that a man would freeze in the shadows and broil in the hot sunshine. But desolate as it seems to be, man will make the moon one of his first objectives in the exploration of space. Here to show us how a future trip around the moon might be accomplished is a noted rocket scientist and space travel authority, Dr. Werner von Braun.
A voyage around the moon must be made in two phases. A rocket ship taking off from the Earth's surface will use almost all the fuel it can carry just to attain a speed great enough to balance the pull of gravity. Unpowered, it will then keep circling the Earth in an orbit outside of the atmosphere. This is the first phase. However, if we can refuel the ship in this orbit with fuel brought up by cargo rocket ships, it can set out on the second phase, the trip around the moon and back. To facilitate this refueling operation, we will establish an advanced base in the orbit, 1,000 miles above the Earth. This advanced base, or space station, will be headquarters for the final ascent to the moon. Our space satellite will have the shape of a wheel, measuring 200 feet across. Its outside rim will contain living and working quarters for a crew of 50 men. Access to the station will be through an airlock in the hub. The entire wheel will slowly rotate at 3 revolutions per minute. The resulting centrifugal force will produce an artificial gravity for the men in the rim. Notice that the floors are placed so that the men stand with their heads toward the hub. The wheel is divided into 9 sections. The first section is headquarters and communications. The next section will be for Earth weather observation and prediction. Military reconnaissance experts, aided by powerful optical and radar telescopes, will observe every point on the globe as the space station makes its complete trip around the Earth every 2 hours. Next is the emergency hospital section, and then the astronomy division, where men will keep an eye on the rocket ship as it makes its trip around the moon. This entire space station will have to be prefabricated and tested on the ground. When the day arrives for construction to begin, the thousands of parts for the space station will be transported to the orbit by our multi-stage rockets. We merely replace the winged passenger section with a simple cargo-carrying nose. These cargo ships will be unmanned. A passenger rocket, 1,075 miles above the Earth, will guide each of the 12 approaching cargo rockets to their rendezvous in the orbit. The cargo ship is floating in space, 2,000 feet ahead of the guide ship. 2 crew members make their way to the cargo head to begin the unloading operation. First, the motor and tanks are detached. Then 2 bottle-type construction suits are removed from the hull. When fitted in the airlock, each of these construction suits will receive an operator. Construction of the space wheel now begins. The sides of the cargo nose are mechanically separated. built-in tanks of compressed air inflate this large plastic inner section of the hub. Thin metal plates are immediately clamped on the outside to protect it from meteors. When the airlock is attached, the pressurized hub section can be used as temporary quarters for eating and sleeping. Each succeeding load is carefully scheduled so that the parts of the station can be assembled in correct order. Nylon ropes prevent the parts from slowly drifting away. Next, the atomic reactor is installed. The wheel begins to take shape now as the three main spokes and rim sections are joined together. Condenser pipes are fitted next so that the atomic reactor may be put in operation. Even though there's no apparent motion, everything in the orbit is hurtling around the Earth at 16,000 miles per hour. The shell of the station is completed. As life on the station settles down to routine, the large reflecting telescopes will begin their work. These giant eyes relay pictures to television screens inside the station. One telescope photographs the surface of the Earth. Another keeps a constant watch on the Earth's weather, while the third is trained on our next objective, the Moon. The primary purpose of the first moon trip will be to test the methods and equipment to be used on later voyages into deep space. It will be essentially a scouting trip around the moon, and no landing will be attempted. To understand the plan of the trip, let us use this model. Here is the Earth with the moon circling around it. Since the first half of the trip will take 5 days, we must aim the ship well ahead of the moon so that they both arrive at about the same point in space at the same time. Here we have a scale drawing of the Earth with the moon 240,000 miles away. This is the elliptical path which our rocket ship will follow, going out and coming back. This model will show you how our future moon rocket ship might be designed. It will be 53 feet in length, has no wings or tail surfaces, because it will be assembled and operated only in the vacuum of space. For the hull of the ship, we are adapting the cabin section of one of the Earth to Space Station passenger rockets. To the nose, we have added a small atomic reactor. The ship's crew of 4 men will be placed 2 in the front and 2 back here. This is the directional radio radar antenna. Located underneath is the airlock for a spacesuit. The suit can be entered from inside the ship. Clustered around the rear of the ship are the 7 extra fuel tanks filled with hydrazine and nitric acid. All but the centrally located tank will be released when empty near the end of the return trip to cut down on dead weight. Even though we now have the theoretical knowledge to make a trip to the moon, it will be many years yet before our plans can fully materialize. However, let us imagine for a moment that the many problems have been solved and that after completing our space station, we are ready to begin our first voyage around the moon.
Ladies and gentlemen, through a worldwide network of radio and television, we are bringing you an on-the-spot account of the first expedition around the moon. Here at Space Station number 1, 1,000 miles above the Earth, the final preparations have all been made. Except for the time the rocket is on the other side of the moon, our radio and that of the station will be in constant communication with the ship during the 10-day voyage. As the moon ship stands by, the all-important pressurized spacesuit enters the rocket's airlock for the last time. During the trip, it'll be used only in the case of emergency. The captain is the last man to come aboard. He will direct the entire expedition from his position at the front of the ship. The navigator, with his specialized instruments, is responsible for plotting the unmarked path through space. The radio operator must maintain constant communication with the Earth and the space station. Finally, the rocket ship's motor and other mechanical functions will be the responsibility of the engineer. After final instrument check, the ship's crew lock themselves in position for the blast-off. Now, only minutes remain until firing time. The captain sets the automatic firing timer and reports to the space station. Last-minute orders are given.
Crew will secure and stand by for firing in 8-4 seconds.
During the first critical 10 minutes, the rocket must build up enough speed to coast around the moon and back. The captain receives continuous reports from the engineer. Sensitive instruments give a second-by-second picture of the ship's progress. The body-racking period of acceleration is over. The ship is on its way. There is no turning back. Weightless now, the crew members must make their first position check along the course to the moon. The stars are signposts for navigation. With incredible accuracy, automatic computing machines instantly give the ship's location in the void of space. This information must be continually relayed back to Earth. As days pass, the monotonous hours of the trip are relieved with various diversions.
Check the console, Joe. Try to pick it up.
Station 1 to
Bill,
RM1.
is your electrical system working?
Emergency condition. Repeat. Verify. Over.
Meteor hit number 2 nitric acid tank. Pressure's dropping fast. It's number 2, all right. Joe, put the air blowers on emergency power. Frank, get in the bottle suit and patch that hole. Don't use your motors near that leak. Try to reach it with the gripping arms.
Station 1 to RM1. Station 1 to RM1. Our instruments indicate emergency condition. Verify. Repeat. Verify. Over.
RM1 calling Station 1.
This is Station 1. Go ahead.
At 51 hours, 22 minutes elapsed flight time, registered hit by a small meteor. Puncture between Station 51 and 52, upper bulkhead of nitric acid tank number 2. Repairs are underway.
Emergency passed, damage repaired. The captain reports no injuries and loss of only 180 gallons of precious fuel. After 4.5 days, the crew get their first glimpse of the unknown side of the moon. At this point, radar contact indicates the ship is only 22,000 miles from the moon's surface. The computer informs the navigator that if the ship continues on its present course, it will crash into the moon. As the 116th hour approaches, the navigator must act quickly to avoid a collision with the moon. He starts the tape selector, which will automatically correct the rocket's course by firing the motor for a precise number of seconds. The instruments show the correction maneuver has been successful. The ship will skim across the face of the moon approximately 60 miles above the surface.
RM1, Station 1. We are now seeing the Earth disappear behind the moon's rim. This will be our last radio message until you see us on the other side.
Roger, RM1. Good luck.
The next few hours will constitute the most important phase of the trip. The moon is sweeping past the ship at great speed, and in the brief span of about 3 hours, all close-up observations of its unknown surface must be completed. As the night side of the moon approaches, flares are made ready for firing. After the barren desolation of the moon, the distant Earth is a welcome sight. Radio contact with the space station is re-established. The ship is homeward bound. After 3 hours of total darkness, the rocket breaks from the moon's shadow into glaring sunlight to continue on its 5-day return trip. The irresistible power of the Earth's gravity has now changed the rocket's direction and is pulling it with ever-increasing speed back to the space station. At 240 hours, preparations are being made to enter the orbit of the space station. The ship's direction is reversed so that the subsequent firing will slow the rocket's speed and jettison the empty fuel tanks.
Firing timer set. Stand by for power maneuver in 3-5 seconds.
Ladies and gentlemen, You have just witnessed the first successful voyage into interplanetary space. This pioneer trip around the moon will soon be followed by an expedition which will actually land on the moon's surface. Even now, construction is going forward on the atomic-powered rocket ship that will challenge the limitless depths of space and solve the mystery of the red planet Mars.